All right. Okay. So thanks everyone who's here today. I'm giving context here both for the people who are watching right now, but also for potential watchers in the future. So I may say some things that are obvious or not obvious to the other group, just to warn you. So hey, I'm Yehudi. I'm an SSI fellow and have been since 2018. And one of my research topics is meta research about software development practices, the people basically who create software and research software in particular is something that interests me. And so I'm going to talk a little bit about automated assessment. Most of what I've looked at was GitHub based, but this is something that I believe will probably apply whether it's GitHub or any other Git-based repo or indeed SVN or Mercurial or whatever else might be cool and working for you this particular day. My slides are CC BY, so if you wish to reuse any of the content, please go ahead. Just say it was Yo who made the original version. So, um, there was a really nice study that was shared, I think January, at the start of this year, 2024, which estimates that there's literally billions worth of dollars in this case that is owed to the open source industry that very often isn't paid for at all. Now, I'm aware of critiques of this paper that suggest that actually the finding is much, much smaller. Um, I don't have space to address this at the moment, but yes, I do know they exist. The main thing is the point that a lot of organizations don't necessarily pay a lot for the software that they use. So this was a study actually specifically on more corporate uses of software. Most of what I'm talking about is academic and research software. So there is some gap here, but I think many of the findings apply on both sides. And I'm not going to actually spend a long time explaining to people who are watching this why open source software or code is important in research. I'm assuming that if you're watching this, you probably already know the reasons that computational power can make research software more robust if well done, or make research more robust if well done is probably a better way of putting that. And as part of that, I think we've all experienced scenarios where you use something and then you come back a year later and no one's updated that library, or something that you depend on just completely stops being updated. And really, what my question is what actually makes software, open source software in general, robust? Also, specifically research software. But there's a couple of ways I think that are more likely to be significant in what makes it robust. So I would say if, core developers leave, or core maintainers in other ways, they don't have to be developers who are writing code. And also scenarios where funding stops or reduces or changes. Why is it that sometimes software can survive these and other times it does not? And so I actually ran a study for the period of around a year, where people were invited to participate by placing a notice on their repository. Most of them were GitHub. I had about 40 repositories in total because one of the requirements to sign up was that the person who responded to the surveys and signed up had to be in the project leadership. So that actually phased out about 100 of the other potential people that could have participated. And what we did when we were researching this is we asked people information about their repo at month 0 of the study. We asked at month 6 and we asked at month 12. Things like what's your staffing like? Do you have interns? What's your GitHub or other repo? And then as well as using these sort of somewhat more qualitative and or subjective metrics, we actually looked at people's GitHub repos when they had GitHub. We did have a few that weren't GitHub, but not enough that it was worth automating the assessments and implementing other APIs for those particular measures. And so one of the things that was quite rare about this is that it happens up front. So people said what they hoped and expected would happen in a year's time and in 5 years' time, rather than just reflecting about the past. And the other was that actually we asked people to place notices on their GitHub repo saying this is participating in a research project so that people could, for example, choose to opt out if they did not want to be surveilled. And next question I ask is actually, do funders care about this? So the reason that I ask this is that it doesn't actually matter too much, no matter how much evidence we produce about the sustainability of research software, if the people who are going to be funding it don't want to help out, even if stuff isn't robust. So on the left, I have an excerpt from an article that was written by Sloan and Chen Zuckerberg, saying that they really want to see things that are usable into the future, and recognizing some of the challenges around that. On the right is an article from the Wellcome Trust that looks at the various impacts of open source software on research and the fact that it is under-resourced. So we can assert that at least some funders care. There's also some information about what makes this kind of, or one way to measure possible correlations between GitHub metrics and sustainability. This is the only metric I know of that tends to actually have anything vaguely useful, but it doesn't give us any information about the causality. So this is a study. It's the link is at the bottom, and it's shared on Figshare, looking at almost 10,000 projects, and finding that on average, any project that had a fork was more likely to exist for a longer time than any other project that didn't have a fork. So I didn't examine forking in my study, but this is the only metric I'm aware of that has any correlation whatsoever with longevity of a software project. Anyway, so this slide, if any of you have read Hitchhiker's Guide to the Galaxy, or watched it or listened to it because it has many iterations, you know all about the computer that was supposed to create an answer to the life, universe, and everything. Eventually it spits out 42, but the idea was great. It's like you calculate these things and you tell us what it is. And so maybe we're looking at something similar here, right? Imagine you get yourselves a GitHub repo URL, you pop it into the computer machine, you get some beautiful graphs and some dashboards, and you're like, yep, that one's really good. That one's not so good. That one's going to die next week. Panic. At least that's the idea. And it seems reasonably simple because we know there is so much information available through the GitHub API, or if you're not using GitHub, just crawling the Git commits or whatever other version control you may be using. And so this is kind of what my study was maybe going to see if we could get some answers using these GitHub repositories. And there are ways to measure these things. On the left, I have a sort of reference to chaos, which stands not for something, a word that's often used synonymously with anarchy, but instead for community health analytics open source software. And you can sort of see from the screenshot I have here that there is a bunch of different metrics that they use: issues closed, response time, number of committers, coverage of licenses, and so many more. I couldn't have possibly fit them all in on this screen. There are lots and lots of different ways to measure software repositories. And then on the right, you can see GitHub's implementation that's natively there that automatically assesses what's going on in any given GitHub repo. And you can sort of see that there is a kind of sickly brown progress graph, and the more things that you have completed, the fuller this will get and the less sickly colored it will get. So for example, it prompts you to add a license, it prompts you to add contributing guidelines and a code of conduct and so on. So these are two ways to measure it. There are a couple of other frameworks out there, but one thing that's very clear when you review literature on this kind of thing is that actually no one really knows how to use them or what they're saying. They have many proposed measures, but whether or not they're actually helpful is another whole question. So it's a very immature science still right now. Okay, my window's in the way of this. Right, okay, trying to remember what I'd actually written on this slide. So here are some of the metrics that I used when I was measuring over the period of this year when I studied 40 different repos. And so sometimes you can get things that are sort of signals of intent of something. And I use this phrase specifically because it's not just because you intend to do something doesn't mean you do it. For example, in community, you could have contributing guidance, you could have a code of conduct, but whether or not you actually have them, it depends, is there follow through? Is there enforcement? Because otherwise a code of conduct, for example, isn't actually useful in any way. So it signals the intent, but doesn't have any real world meaning unless it is actually used. There are things like people might say, oh, it's on GitHub, so it's open, right? But it may or may not even have a license, or it might have the wrong kind of license to actually be applicable to the content that it's using. Some of the other things that are really easy to measure in the yellow boxes, there's looking at the code base, like number of lines of code, number of commits, number of committers. I honestly couldn't see anything useful there beyond the fact that perhaps that more committers means there's a larger community and therefore more sustainability. But even then, it's easy to understand those metrics, but not all that easy to draw things from it. Because even something like number of commits, if you have a bot that does commits for you or deployments for you, then it changes so much between repository to repository, makes it very hard to be useful. And then there's behaviors like pull requests and issues, maybe mean or median time to close or resolve those pull requests and issues. And so I measured a lot of those as well. I also tried to measure mentorship, but most of the communities that were in the study didn't have much mentorship. So no evidence of interns just about any of the projects. So I felt like there wasn't enough information to even say anything about that here. Moving on, no? You can do it. Come on, little screen. There we go. So as I said, 40 participating projects, surveys at 3 points, at the start, at the middle, and at the end, learning about funding, staffing, and what people intended and expected from their repository. So for example, if you know that you're never going to have more than 500 users, I knew that I shouldn't be comparing you to, I don't know, Pandas, which probably has a few more users than that. So understanding the scope of what something was expected to do was very important. Also, similarly, sometimes research software is intentionally retired. For example, you may know that you're going to use it for a year or for 2 years, and then you're done. And that's cool. And again, you should obviously make sure not to compare that to something that actually does want to sustain for a long time. And make sure that you're understanding the different motivations behind them. GitHub, we looked at those pulls, issues, commits, license, README, and contributing guidelines. People didn't like me asking them to warn people that I was going to be studying them, which I was surprised because I know people also don't like being stalked. And in essence, me writing a commit and then getting spam a few years later from a researcher saying, hey, will you do this study? I've also not appreciated that. So it ended up feeling a bit odd that in some cases people were very resistant to me saying, let's put the short notice on your README or on your issues or wherever you think makes sense, just so people know. So I'm not sure what the right way to do this is, but I do know it's not straightforward and not as easy as it seems to actually do the right thing, because people may push back when you're doing something that's already defined as not the right thing, or you may be trying to do the right thing and still get pushback. So that's more of a comment on the curiousness of going through a project that's looking forward prospectively rather than looking back at the past. And what we ended up with were a bunch of really interesting case studies. And I couldn't possibly have done this without at some point including this XKCD. It's basically whenever we talk about software sustainability, not from the green point, this comic will come in. But one particular case study which utterly terrified me, like almost everyone who watches this will have, if you've ever used this particular language, you will have used this library, had 2 paid staff, and yet up to maybe 5 million users over this period of time, and not all that many contributors. And whilst they did have funding, it was literally partial salary support. So actually understanding what helps when people are like at this dangerous cliff edge, which is so easy to fall off, I think this sort of emphasizes just how important some of this is. All of this data, by the way, is deposited openly on Zenodo. So if people want to look through the surveys, you can get all of the answers. It's anonymized, so you cannot find out which Git repo it was, unfortunately. But it still does have a lot of very interesting information and interesting case studies. Another case study of the people creating the software, which is mostly research software, only 23%, less than a quarter, had a permanent paid contract to work on this software. And that was at the best time point across all three. So it's very, very precarious in terms of people amongst leadership who are maintaining things. I also found that GitHub is not very good at detecting what exists. So especially with older repositories, but not exclusively older repositories, it may not recognize things. So for example, this on the left is a screenshot saying this repo doesn't have a license. On the right, it took me moments to find the license file. I think it was inside a document folder or something like that. But it was enough to throw it off. So I don't quite trust GitHub. I think it does a great job at trying to do things and encouraging people to do the right things, but it's also returns a lot of false negatives. It doesn't tend to return false positives. If it found the license is there. A bit like a COVID test. Ha. Okay. Similarly, developer guidelines were super clear. They were right there, and they were not picked up by GitHub. Because of reasons like this, my scripts also try to detect things in a more manual way to try and find things. So this is not to say that only like all metrics are bad because GitHub doesn't assess them right, but also that they can be hard to find generally, perhaps. And there's not always a consistent way to do things, even when it's very clear to a human within moments. And I think the biggest finding that I had from all of this is that there is utterly no consistency across projects. So what I have here is projects organized by size. The one that had about 5 million users is one of those other please specifies at the top. But what you can kind of see is that actually projects that had similar sizes had radically different funding. For example, the project near the top, founded in 1975, had almost no paid people over the whole period of the study. And it has the same size as the one that had tens of paid people, but was actually significantly younger. And so there's a lot of disparities. Disparities? Yes, that is a word. Actually looking through all of the different projects in question, it's very, very easy to find projects that break any rule that you try and look at when you're trying to understand what sustainability is. Okay, hold on. I'm just going to mute for 1 second. Okay, right. Hopefully you can't hear builders in the background. Very sorry about that. Old and young projects had similar time to close when we were looking at issues. So again, there wasn't much commonality across any of these. I can explain what these graphs are. I know it's probably a whole lot of data on a very small screen, but I won't dig into it too much right now. And so going back to the old idea that we were looking at earlier, we were saying, so we input a Git repo and we get a scoreboard. And right now, every time I looked at my data, I did so many different kinds of graphs, trying to visualize things in different ways, visualizing issue closure over time, pull request median time to close, all of these. And no matter what, I could never find any consistency, anything that would not misjudge many of my projects, because we were only judging some of the projects fairly. So worrying whether or not that scoreboard was actually going to be meaningful in any way. Or thinking back to what we were saying earlier, we put the GitHub repo in, we get our fancy stats, and then strange pink Donald Trump rides the piggy bank to profit. Actually, more like what we had was we input the repo URL, we got chaos and not kind with 2 S's for assessing open source software. And then we cried for a long time because there was no story, literally no story to tell in these. But eventually I realized that actually that was the story. And I think that I have a feeling for what's going on here. And it's, should we have even been looking here? Really? So if we think about this, what we're trying to measure is community sustainability, right?
Yeah.
Um, and um, sorry, I've people walking back and forth, and it's a bit hard to concentrate. Yeah, we're trying to measure community sustainability. And so communities, they have meetings, they have discussions. The PI might write a grant if it's an academic or research project. And one second, sorry. Okay, right. Sorry, it's very hard to concentrate with noise in the background. Um, yeah, people have different community behaviors. Um, and if a PI is writing a grant, I even had scenarios where the person who participated in my survey hadn't written a single line of code in the code base. Um, and I think this is actually a survivorship bias thing, or perhaps a better way of looking at it is if you're familiar with what's called the drunkard search. So there's a story about a guy who was quite drunk late at night, and a police officer walks over to him and sees him searching. And he says, "Hey, what's wrong?" And he says, "Oh, yeah, I've lost my keys." He's like, "Right, where did you lose them?" And he says, "Over there." And I said, "Well, why are you searching here?" And he says, "Well, this is what I can see." I think this is what we might be doing with GitHub, is we're looking for evidence of community behaviors and something that, whilst it does have some community interactions, is fundamentally something that's designed for code. And so we're looking in the wrong place for the evidence of what makes sustainability. So this is not to say that actually there's nothing meaningful in GitHub. I think there's plenty. But I think that there's too many ways to misinterpret what's going on unless you get additional context. And that could be things like talking to a developer, talking to community members, and understanding the bits of context that will not make it into the light, that are out in the darker sections here. Um, so I have a bunch of questions that I really would love to answer because like some of these things I couldn't define is one of my defining characteristics of every single study I do is I end up with more questions than answers and a lot more questions than I went in with. For example, I think I mentioned PIs and managers who have absolutely no presence in the code. People often didn't know if they were employees or if they were paid to work on something or not because they were working in kind. And either they were supposed to be working with in kind, or maybe they were secretly doing it, or maybe they were only doing it in the evenings because their boss was already pissed at them. So there were a lot of different scenarios. People cannot even define themselves um, what they what they're able to contribute. And I'm wondering what on earth liver-lived communities means. I think it probably longer, but yeah, I'm not talking about any livers here. I think, yeah, those are all the slides I had to present. I hope it was coherent, especially since I got distracted like 3 times throughout. I'll stop sharing. Any questions, my friends?